Thanks, Ewan. As Ewan says, I'm Jamie Noble from Home Energy Scotland. I'm going to talk about, give a brief overview of renewable technologies and go into things like funding and consideration. So just before I do that, I'll just a reminder of who we are. So Home Energy Scotland is a Scottish Government funded programme, and that's to provide impartial energy advice, so advice on anything from insulation to renewables. We also give advice on government funded schemes, and as you can see at the bottom, we don't cold call. I'm not going to go into detail of different technologies. We don't have time really today. It's just to give you an idea of what we mean by renewable technologies. So to begin with, I'll talk about renewable heat. So we have heat pumps. Heat pumps essentially transfer heat from the environment into your home. So you have air source, ground source, and water source. Usually they emit the heat using radiators or underfloor heating, but can also you can also have warm air systems as well. With heat pumps, they're using the heat from the environment, so you're getting some of the heat is renewable and some is from the grid. So they will, if they're electrically powered, they'll use some electricity. So if the heat pump's around 300% efficient, for every unit of electricity you use, you get 3 units of heat into the home. So it reduces the amount of electricity you need from the heating system. So what that means in kind of cost terms and unit cost terms. So if you had an electric tariff of say 15 pence, that if your heat pump was working at around 300% efficient, that'd be 5 pence per unit of heat. And if you're looking at say an oil condensing boiler at 47 pence a litre, and the oil, the unit cost of oil there would be just over 5 pence. So it's comparable kind of in terms of unit heat costs with oil. There are other considerations that we would go through when we're giving advice there on heat pumps as well. Moving on, biomass. So what we mean by biomass is, in terms of heat, is wood fuel. So that could be logs, wood pellets. Less common is wood chips. So that can either be a standalone stove or it can be a wet central heating system. In terms of unit costs, they'll vary between the different fuel types and where you're sourcing. So if you're buying in, say, well-seasoned logs at around about £190 a tonne, you'd be looking at round about just over 5 pence per unit of heat into the room. With pellets, about £300 a tonne, you're looking at about 7.4 pence. So slightly more expensive than logs, but can be a bit more controllable in terms of central heating. You've also got solar thermal, which absorbs energy from the sun to usually provide hot water into the house. As you would expect, as it's taking heat from the sun, most of that generation will be in the summer. So you can get up to about, you can get up to 100% of your hot water needs in the summer. Overall, throughout the year, you're probably looking at 40 to 50% of your hot water needs. In terms of suitability, generally you would site solar thermal on a pitched roof, and it would ideally be facing east through to west through south. In terms of renewable electricity generation, probably all aware of these technologies. So it's using energy from the sun, wind, or from the water flow. With solar PV, as you would expect, again, the majority of the generation is in summer, but you will get some generation throughout the winter. PV tends to be more suitable for most people, as you would expect, where you've compared to wind and hydro. With PV, again, you'll be looking at a suitable site where you can face the panels on a pitch, east through south to west facing. Wind turbines, you would need a site where you have undisturbed wind flow, ideally over 5 meters per second. Micro hydro, you would need access rights to a stream, burn or river, and you would need to do some site calculations on things like the head, which is the height or the fall, and the flow, which is the speed of the flow. We can also advise on energy storage to complement renewable heating systems. So they can come in the form of either storing as heat or storing as electricity. Thermal stores, you may be familiar with thermal stores, so they could store hot water for either central heat for heating and hot water, or just for hot water. You can feed in, so typically with a biomass system, you would require a thermal store to balance out the system. And for things like log boilers, you would want a big thermal store to heat up enough hot water to heat the to provide your heating and hot water for the day. You can also feed in electricity through an immersion heater using what's called a diverter. So any electricity that you generate from PV that you don't use, rather than exporting to the grid, you can provide heat to a hot water tank. There's also heat batteries, which you might not be as familiar with. These are a salt-based, what's called a phase change material. The advantage of heat batteries is space, basically, so you can store more heat per volume with a heat battery. They're a bit more expensive, but if space is an issue, that could be a solution. You can feed, similarly with a heat battery, you can feed in different renewable sources. So you can feed in biomass, heat pump. You can also feed in electric generating technologies like PV and wind. Electric batteries is probably aware, familiar with. You can get home batteries that you can connect up to your PV or wind or hydro, which can store electricity that would otherwise go to the grid. So if you've got a PV system, you're out all day and you're not using the generation, you can store that up for later. I've also put electric vehicles there. Essentially, electric vehicle is a big battery, but you can get smart devices to work alongside your charger to provide trickle charges into your electric vehicle when your electric your PV or your wind is generating. Considerations. So the first one for most people is space disruption and costs versus the benefits. So the benefits could be anything from savings, incentives, environmental benefit. And as we talked about insulation and fabric last week, so very much take a fabric first approach. We want to reduce the amount of energy required in the home before we look at as much as we can before we look at heating, or even looking at generating electricity. When we're advising, we do look at people's lifestyle, their occupancy, so that will come into what's more suitable for people. Maintenance as well, we'll talk about. So we've got varying degrees of maintenance between the different renewable technologies. So with PV, it's very low maintenance. With biomass, you'll have higher maintenance, ongoing maintenance, like cleaning, and with biomass boilers, servicing as well. We'd also, in our considerations, quality assurance and customer protection. With renewables, if it's what's called an MCS accredited installer, they require to be registered with consumer body like Renewable Energy Consumer Code, and that gives consumers extra protection against things like hard selling and mis-selling. And our consideration is electric meters and tariffs. So if, for example, with electric batteries or storage systems, you could look to use, take advantage of off-peak tariffs. So storing electricity at off-peak times to use at peak times, especially if you're looking at with PV. In winter, the battery will still be in use, and the PV won't be feeding the battery as much, so you may want to look at an off-peak tariff to go with that. Fuel supply as well, when we're looking at biomass, the renewable part of it is with biomass is make sure it's from a sustainable source, and it's the supply is as local as you can get as well. So renewable funding, so you have the Home Energy Scotland Renewable Loan. It's for heat pumps and biomass. That's up to 10,000 available, and that's interest free. There's a cashback scheme running at the moment where of that 10,000 you can get up to 75%, up to 7,500 cashback. For solar thermal, there's up to 5,000 available, interest free again, and there's 75% cashback up to 3,750 available for solar thermal. For renewable generation, electric generation, it's interest-free loans. So for PV, it's up to 5,000, no cashback available, and for wind and hydro, it's up to 2,500. There's also the renewable heat incentive for heat pumps, biomass, and solar thermal, and that's a payment would be paid to you over a 7-year period, and that's paid quarterly. There's also the Smart Export Guarantee for renewable electric generation, and that's essentially an export tariff. So any electricity you don't use and you export into the grid, you'll get a payment from obligated energy suppliers. Other funding that's not renewable specific, but does include funding for renewables. So there's Warmer Home Scotland. So that's criteria based, so based on things like benefits and age, and that's an upfront grant for insulation, heating and renewables. Typically the renewables will be air source heat pumps, but there is funding available for solar PV, solar thermal. They have in fact put in ground source as well, and biomass. There's also area-based schemes. So through the Highland Council, they have a heat pump, air source heat pump scheme, and funding available for that. They also are looking at a solar PV and battery scheme as well. There's also what's called eco-funding, which is which is energy company obligations. So that comes from obligated energy suppliers, and that can also include renewables as well as insulation. In terms of support, you're lucky enough to have Ian Bush, who can support you through the process. His details are there if you need to take them. Home Energy Scotland's also there. So generally speaking, we'd if in Garve District, that would be referred via Ewan Bush, or you can call us directly on the number there. There's also what's called Green's Homes Network. So that's people who have already installed renewable technologies and as well as insulation, where they are willing to speak to people interested in installing. You can visit when when restrictions allow. We can arrange visits to houses, but at the moment we're not doing that. So thank you very much, and if you have any questions, please ask.
That's great, Jamie. Thank you. Anyone got questions? I've got a few here.
Yeah, I've got one. I suspect it's the same answer as the one I asked last time. The funding that you're talking about there is presumably limited in the same way by the council rating?
So the area-based scheme, yeah. So the Highland Council one, you mean? Yeah. So that's based on council tax bands. So council tax bands A to D. Yeah. But
the other ones aren't then?
No. So the Home Energy Scotland loan and cashback is it's basically if you're owner occupier. There is credit checks on that, but yeah, anyone who's an owner occupier can apply for that. And similarly with the renewable heat incentive as well and smart export guarantee.
Great. I'll ask a few questions, and then if people come up with anything, do let us know. So is there cash back on solar PV?
No, there's not.
No. Okay.
No. So it's only for
Jason,
only for only for renewable heating. Yeah.
Okay.
Yeah.
What's the most common? What's the most sort of popular heating system at the moment, or historically? How have you seen it shift?
So so it shifted from wood pellets to air source heat pump. Initially, when the renewable heat incentive started, the incentive was for putting in wood pellets was a lot higher than it is now. Heat pumps have pretty much stayed the same. It's actually gone up, the incentive for heat pumps. So the focus is probably more on heat pumps now.
Do you think that was anything to do with the suitability, or as well? Because sometimes you see government funding can skew what's if simply because there's money available for something, somebody might go for it rather than it being the appropriate.
I think it's becoming, because it's becoming a bit more common, people are becoming more familiar with it as well. And there's probably been a lot more successes with it.
With the
compared to when, I mean, the first ventures into air source tended to be social housing, and it was very early on, and varying degrees of success there with the installation. But as things have moved on, technology's improved, installation quality and designs improved. It's becoming it's seen as a more viable option by people that are speaking to their neighbours and so forth.
Great. I'll carry on. If there's no one else at the moment, so Green Homes Network. Is there anyone in Garve area or Outwith that's
I can yeah, I should really check that. We are, I mean, I suppose one of the questions get often asked in Garve is about what temperature they'll work down to. Understandably, a lot lower temperatures in Garve. So I can't think offhand any in Garve, but we are recruiting. We have recruited people in kind of Benedict and Strathspey, where you've got similar kind of cold temperatures that have put in air source with successfully.
Okay, great. Well,
Could I ask, the options that you've listed, are they written down anywhere on a website we can go and have a look at?
Yeah, I can share that in the chat if you want.
Yes, please.
Yeah, I'll just bring it up. I'll put it in at some point. Yeah.
Okay.
So the options of the heating systems or the funding or both.
Both.
Both. Yeah.
I'm finding it difficult to get sources of information to work out what funding is available for what and from whom.
Yeah.
Thanks.
Yeah. So I'll bring up the main page.
Can I ask, Phil, are you interested in all options, or is there a specific technology you think might be appropriate for you, or keeping options open?
Well, been looking at originally ground source heat pumps, but the cost is quite prohibitive compared to funding that's available. You know, you need to have 10, 12, 14 grand spare on top of what's possible to get funded. So, I mean, the same as other people have asked, will an air source heat pump work sufficiently well when it's really cold out compared to a ground source or not? You know,
Okay.
it's difficult to know about this unless people had, you know, like Mark, for instance, he's getting a new one put in now. So it's generation is better than John Fenwick's air source heat pump.
Yeah.
That it would work down to lower levels at a better level, but I don't know. And
yeah, we can ask these questions of Jason as well when it's his turn. So he should be able to give us some information there too. So I think we should move on. Thank you, Jamie. We've now got to Gordon and Kate from Fintree, I think. If you're ready, that would be great.
Okay. Okay, is that visible?
Yep.
Perfect.
Okay, great. Okay, thanks again for having us along. Yeah, so we've focused the presentation we're doing on work we've done over the years in low carbon heating systems and also PV installations. Low carbon heating in particular is something we've done quite a bit of over the years. So it's very much a kind of key part of our work. You know, it reduces the carbon footprint of the village and simultaneously addresses fuel poverty. As I said last week, I think I said it anyway, the village isn't on mains gas, so the amount that people spend on their heating is quite a kind of hot subject for people. So we've done quite a few kind of specific projects, and I'll talk about some of these in more detail. So we have done a biomass fueled district heating system for 26 park homes. And that went live about 6 years ago now. We've assisted with the installation of biomass heating in both the local sports club and also the Fintree Inn. We almost installed a shared loop ground source district heating system for 20 homes. And I'll talk about that a bit more and you can find out why it was almost. And we've also done quite a lot of supporting the installation of domestic micro renewables through energy advice and so on. I'll talk a wee bit more about that later on as well. So that's just a couple of pictures of the biomass boiler. going in for the sports club.
Very much a village activity, wasn't it?
Yeah, 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 and quite a few years ago now, looking at that picture, I think those kids are now 6 feet tall. So it was a while ago, and that's that kind of heat. There's a sports club has a bar and a cafe. It has a large indoor bowling hall. It's got squash courts and a gym. And various other, it's about to have a museum added to it as well. And it's all heated through an air heating system. So the biomass heats that air heating system, which then gets the heat pumped around the building. As far as solar PV goes, we've done a few things here. We installed a PV system on the roof of the primary school nursery, and again that was a few years ago now. And the feed-in tariff funds that generates go to the school for other projects that the school does. We helped with the installation of a 50 kilowatt solar PV array on the roof of the sports club. So particularly the roof of the bowling area is kind of ideal for solar PV. It's kind of slightly slanted and faces more or less south. And we've also supported the installation of domestic domestic solar PV as well as that. Yeah, one of the things that we've done over the years, we're not doing so much of it now, but it was really kind of one of the most successful things I think we've done was we employed an energy advisor on the staff, and a large part of his role was really to kind of facilitate, to help people do the right thing, if you like. So, you know, either because of, you know, for financial reasons or because they thought it was the right thing to do. A lot of people wanted to reduce their energy use or switch to using renewable technologies, but it kind of just lots of hurdles there get in the way. So we employed an energy advisor. We actually had two different members of staff over the years, but the one who was with us the longest was Matthew Black. And he just helped people through the whole process of choosing a system, of choosing an installer, of selecting what was the right technology, helping kind of fill in application forms for loans or RHI or feed-in tariff. Other things we're able to do, as it says there, was we're able to do some bulk buying. So fairly early on, we had a collection of people. I can't remember how many it was now, but kind of getting on for 10, I think, folk who were wanting to fit heat pumps. So we're able to do a bit of a deal with heat pump installers on that. And then we're also able to ask folk to be kind of demonstration homes, if you like. So other folk who were interested in doing it could go along to their neighbours and kind of see how the system worked. And I think actually that kind of thing is really powerful. I think the idea, I've seen it kind of described as people like me. You know, if somebody you know has kind of taken a step that you're thinking of, but you're not sure, but you kind of trust them and it's working out for them, I think that's quite powerful. And then we also had our own household grant scheme to help cover the cost of installation. And one of the facilitation things we did was provide very short-term loans so that we could give the installer a deposit for going ahead with the work before the householder was able to apply for the Scottish Government loan. So just kind of bridge that gap, I suppose. And say that was a really successful process. We got a lot of people switched to heat pumps, air source and ground source, and some pellet boiler installations as well. And that's Matthew. That was our energy advisor, cuddling some solar PV, and in the bottom there's a ground source heat pump installation. I think that was one of the first ones we had that went in, and a pellet boiler there as well. So kind of specific projects that we did, that we've done, the biggest one was probably this biomass district heating system, where we have installed a 200 kilowatt biomass boiler, which provides heat to 26 homes that were hard to heat, and for many of the people, they were in fuel poverty. That system has now been in place since 2015, and it's supplied somewhere around 3 gigawatt hours. I was doing this, kind of putting this together the other day, and I was thinking, is that number right? That seems like an awfully big number. I think it is right, but if I've got my decimal point in the wrong place, don't shout at me. We did have some initial problems with reliability of the system, where people kind of ended up without heat and hot water from time to time, which wasn't great. But for the past few years, anyway, it's been pretty reliable and worked really well. And we've actually just done a survey of the householders, and the responses are really kind of very positive, which is great. However, the kind of fly in the ointment of this is that the system has kind of quite high heat losses and high maintenance costs, which means that we've had to subsidise it out of other funds, which isn't really kind of what we want to be doing. And it's a big enough problem that we're kind of wondering what the solution is for the system in the long term, because it's not something we can continue doing forever. So we're trying to work out how to solve that problem at the moment. And that's on the left-hand side picture there is the boiler itself. And then the right-hand picture is some people looking inside a heat interface unit, and heat interface units are where the heat that's going around, the hot water that's going around the district heating system kind of meets up with the water in the radiators in the house, and the heat gets transferred from one to the other. So each house had one of those green boxes installed outside it. Then another project, and this is the one that we almost did, was this shared loop district heating system. So we had about 20 homes on a single street that all had fairly expensive and not very kind of well designed electric heating in them. And the plan here was to create a shared ground loop. So this had multiple boreholes kind of in the street, and then the ground loop kind of connected up those boreholes with each house, and then each house had its own heat pump. And it would have been one of the first projects of its type in Scotland. I think there's a few in down south, but one of the first in Scotland. And we were all set to go. Kind of had householders were up for it, and we had kind of partners involved in the project and so on. But when the drillers came on site to drill the boreholes, they discovered that the rock underneath the street, quite far down, was fractured, which meant that the boreholes just kept kind of subsiding into themselves, and they just couldn't bore a good hole. So sadly, the project had to be abandoned, which is a bit of a shame. The good side of this, I suppose, the kind of positive part of it, is that quite a few of the householders afterwards installed their own air source heat pumps instead. So quite a few of the expensive electric heating systems were replaced anyway. But that was one of those projects that almost happened, but not quite. And that's it. Yeah, that's the end. So, yeah, happy to answer any questions if anybody's got anything.
Just one that came to mind was the big biomass boiler. Was that wood chip or pellets?
Yeah, it's chip. It's wood chip rather than pellets. Yep.
So was that easy to source, or the deliveries, has that been a problem? Or?
Yeah, no, for the most part that hasn't been an issue. So we have a heat supply contract on it. So there's a company, it used to be called Highland Wood Energy, they're now called AMP Energy, I think. And they have the contract for the supply of the wood chip and for the maintenance of it as well. And we pay for the heat that's used. So we're not actually paying for the wood chip by the ton. We're paying for the heat that it generates.
Okay.
And the same for there's a fraction on top of that for the maintenance. It's on the same basis as well. And I think the wood chip.
Is that the sports hall and?
Yes.
So I was just wondering if that the same systems.
Yeah, both systems are they have the same wood chip supply. The sports club boiler, that's not something that as a development trust we own. That's owned by the sports club itself. So we don't, although we kind of helped make it happen, we don't have any kind of day-to-day involvement with it. But they both get chip from the same supplier.
Great. Maybe we could ask one of the questions Phil was, concerned about the air source heat pumps and the private ones that were installed. Is there generally, are people satisfied with them? I imagine you're quite high up there as well. It can get quite cold in the winter. And
yeah, it's fairly chilly in the winter. It's probably not as chilly as it is with you. Yeah, no, as far as I'm aware, most of the folk who put in air source heat pumps are quite happy with the heat they get out of them.
Yeah. I've got a 1780s stone cottage and an air source heat pump, and it works. It's not the cheapest thing, but it works. And I've not had any sort of major issues with it, sort of not coping with cold winters, and that's through Beast from the East days and all the rest of it. So it's managed much more efficient. We were on oil before, and the cost difference is quite incredible.
So it's you feel it's cheaper than oil, or?
Yes.
Oh, that's good.
Yeah.
Great. Okay. Anyone else? But if anyone's got any questions that sort of crop up afterwards, you can, if we've got time, we can still go back to that. But that's really interesting, and it's great to have you along. And thank you so much for taking the time as well to do this.
It's good. It's good to be here.
Yeah. Brilliant. So who's next? I think it might be Jason.
Yeah.
Oh, okie doke.
Yeah.
All right. We're all still sitting comfortably. So let's do the share screen thing. How about that one? Can you see that, everybody?
Yeah.
That's
Yeah,
perfect,
and can you hear me
Jason.
okay? Just
Yeah.
yeah, good stuff, good stuff. So hello, I'm Jason Leon. I'm sort of almost one half, if you like, of a company called Onsite Generation. I'm the northern half of it, and based in Ullapool, and I've got a business partner who runs things down in the sort of central belt. We started off doing very similar things, consultancy and installation stuff, and we've sort of, yeah, we've diversified a little bit. Richard does now bigger sort of project support, so he's doing a lot of solar co-op sort of work at the moment, and has been very involved in that sort of thing. Whereas I've been doing, yeah, more small scale renewables have just continued with me, doing some government consultancy work for small businesses, but yeah, quite a lot of small heat pumps. To be honest, mainly heat pumps and PV systems, and mainly air source heat pumps. So that's what I was going to talk about today, if I can. Let's see, is that not working? There we go. So yeah, if that's all right, solar PV and air source. You know, Jamie started off, didn't we, with there are a lot of choices, aren't there, with renewables and batteries and all the different storage systems, and it's quite a, yeah, it's quite a minefield to get through what's the best for you and what's going to work. I think we've certainly found that air source is probably the easiest to put in, and as long as you do it right and do it so that it's designed properly for the property, then it will work, and it will work well. There are occasional times where you turn around and go, actually, no, it's not going to work in this instance, and you pull away from it. Yeah, I adore solar PV for its simplicity. It just does what it's meant to do. So as long as you've got the space for it, PV is, I think, yeah, a great technology, and probably the simplest of all of them. So with PV to start with, just to confirm, you know, clarified, solar PV is photovoltaics, which it converts electricity converts the energy and light into electricity. So it generates electricity, not hot water, at least not hot water straight away. The generation feeds into the building's electrical demands. So the idea is that you just wire into your consumer unit in the building, and whatever you've got on at that time when you're generating will use the electricity that's being generated by your solar panels, in preference to pulling electricity from the grid that you have to pay for. It's as simple as that. But that in mind, you'll generate during daylight hours and you won't generate during the night. So you're on your own at night time. It's as simple as that. And you get best generation in the spring and summer months. May is actually the best month. You'll get most in May, just May, then June is a close second. And you'll do reasonably well in July and April. And yeah, as you move into winter, less well. And to be honest, when you get towards November, December, January, February, you're really not getting a great deal out of it at all. Yeah, to low levels. Typical system size, you're looking at something around the 3 to 4 kilowatt size for a domestic property, but you know, up to anything else if you're looking at commercial. 50 kilowatts was mentioned just before, wasn't it? So that sort of thing. So you can go up to much bigger, but typical domestic scale is around that 4 kilowatt size. And you would look to generate, and I've checked with Garve particularly, you generate something around the 750 kilowatt hours for every kilowatt of power that you have on your roof. Okay, so a 4 kilowatt system would give you about 3,000 kilowatt hours a year to use in your house if you can. Okay, so some of the practicalities of it, you need to have a space that faces southerly, if you like. It doesn't have to be bang on south, and I get asked all the time, oh, but this is a little bit to the east. It honestly doesn't matter too much, particularly these days that panels are now so much cheaper than they used to be. You can almost just bang them on, put the panels on wherever you've got space to put them on. You wouldn't put them usually in a northerly orientation. You wouldn't have them sort of north of that east-west line, but yeah, I've seen it done, and it just depends on what you're trying to achieve and the angles of your roof and everything. But even if your ridge line was essentially east-west, so it was north-south, and you had a west-facing roof and a south-facing and an east-facing roof, then you could put panels on both sides these days quite happily and and generate like that. You look for an unshaded location if you possibly can, but you can deal with a little bit of shading every now and again if you need to. There's clever ways around that. I looked at Garve earlier on. There's this lovely little website called, it's just Google PVGIS, and you can go into the little map there and you can pinpoint your own home, and you can look really, really closely at what you'd get out of a system on your roof at whatever angle your roof is at. And yeah, whatever your angle is to south. So this is a system that is 4 kilowatts in size on a 35-degree roof facing south. And you can see that if you look at, I don't know whether you can see my pointer here, but in May, you're at just over 400, maybe 420, 430 kilowatt hours of electricity generation during the month of May. Okay, so it shows you what, the difference of what you're going to get during those summer months compared to what you're going to get during the winter months. And it's pretty bang on. It really is pretty bang on. There isn't such a thing as an average year, but it takes the an average for what you like to get, and gives you a very accurate idea of what the generation would be at your location. So pretty good. So what you need is space for the solar panels on the roof. You need then to connect them in via an isolator into an inverter, which can go in a cupboard or in a loft or something like that. You then connect that through to a meter that records what you're generating, and through another isolator, and then to your consumer unit, and into the demands in your house. The inverter converts the DC electricity that comes out of the solar panels into AC electricity, so that it can just go back into the grid, and then you're away, and it just goes into anything that you've got switched on. These are my solar panels. So I've got 10 panels on my west facing roof. These were the first ones that I put on quite a while ago now, and they're still looking pretty good. And I am looking sort of towards the sea, facing west, in a pool, so they get a bit of a hammering every now and again. These are my second set of solar panels. They're on my east facing roof. So that was put on a little bit after those first ones, and then I actually had an extension built and put on 3 more just for the hell of it, which are in-roof panels. So these are slightly different to those ones. Those ones sit proud of the roof surface. So you fix them onto the roof, and you lift tiles up and you move them around, and you fix into your rafters with brackets, and then run rails. You can't really see the rails. You can see the rails at the edge of that one there. So they need to be screwed into your rafters, and you need to do some roofing work with your tiles or with slates if you've got them, or if you've got an opportunity to strip things back or start from fresh, you'd put them potentially in roof, which is the way all new builds are done these days, with in roof panels that are flush with the roof line, and save a wee bit on the actual cost of the tiles, because you haven't got tiles underneath these. They are the roof surface itself. Okay. So we've said that generates electricity. Usual system's about 4 kilowatts in size. Panels have changed in their capacity over the years, and they're still changing almost monthly. They're getting more efficient, better. They're squeezing more generation into the same sort of size. So these days panels can be up to around 400 kilowatts, so 400 watts per panel these days. Slightly longer panels are your 400 watts panels. So you'd look at somewhere between 10 to 12 panels on your roof. Older systems were usually 16 panels. So we've dropped the number down because we can squeeze more generation into that amount. So we said your 4 kilowatt system would give you about 3,000 kilowatt hours a year. Now there are no feed-in tariffs anymore, or grants. So what you have to be able to do is take that 3,000 kilowatt hours and usefully use it in saving money off your bill. Okay. If you were able to save a full 3,000 kilowatt hours a year at say 18p a unit, you'd save about £540 a year on your annual bill. Okay. You won't be able to use all of it, or it's very unlikely that you would use all of it, but you might. But that's the maximum that you'd make out of a standard system, about that £540 a year off your bill. Okay. The alternative to that in a straightforward system is getting money for just letting it go back onto the grid, so exporting it. And Jamie mentioned the the smart export guarantee, which you have to sign up for. You need a smart meter for, and that smart meter records what you're exporting. And if you set it up properly, you'll get probably about 5p a unit. So exporting will give, if you exported all 3,000 kilowatt hours, you'd get 5p a unit for that, which is £150 a year, and that's all you'd make. So you really want to aim for maximizing the self-consumption of the system. So using as much of your generation as you possibly can is the way to get the most out of it. Where to put them? Love sheds and adore sheds. So any good sheds, metal roofs are fantastic. So anything with metal roofs is the easiest and therefore the cheapest way to install PV. Really straightforward. So anything like that, or this is what we did actually last Thursday. So if you've got a newish, good quality roof, this one wasn't a new roof that we it was put on when the roof was made new. You strip off from the ridge and you come all the way down to where the panels end. You remove those tiles, you put the PV panels into the roof, and then you redress the tiles around the system, just like you would with a Velux window, that sort of thing. It's got very similar flashings that go around the panels, but it's doable on existing roofs. Yeah, that's 10 panels, and it took a day to put that on the roof. If you've got no roof space, then maybe you put something out on the ground. If you've got roof space to put it on the ground, again, facing southerly is fine. So yeah, and it can look quite good, and yeah, a bit of a DIY project perhaps, but you can put something together. Slightly bigger systems, commercial systems, if there's a commercial building, again with a metal roof, ideal for that sort of thing. And this is a campsite and it's got lots of electrical loads. There's a shop next door with fridges, so they're running all the time. The fridges were really toiling in a very hot shop, which was causing trouble. What we also do with have done with this one is we've put the PV generation goes into one of those power diverters that I think Jamie mentioned, and you can get an app on your phone that monitors what's coming from where. So in this instance, you've got 8.4 kilowatts coming out of the solar panels. It's going into the building. 100% of it is being, well, it's not 100%. It's what that's saying is it is 100% of what the building is being used is being supplied by the solar. So the building is using 4.7 kilowatts, which is all being supplied by the solar. 300 watts are going into heating hot water with the immersion controller, and there's 3.1 kilowatts going back out to the grid. So you can see very clearly where it's all going and what you're managing to achieve by doing it. So it's good. I just wanted to show you this bit as well, which is that this is the design details. So given the location and what you're looking at and what you're trying to achieve, there are some design packages that are really sophisticated, and they know exactly where the roof is. They know the orientation of the roof. They take all that information from Google Earth. They know how bright it is on average at that location, and you can put in all sorts of information to get a really accurate idea of what the generation would be, what the self-consumption would be, and then for what the value would be to the customer. And you can then add batteries into that system as well and look how that would increase the value of what you're trying to achieve. So it can be really detailed. Something a bit more commercial. We mentioned electric vehicles as well. So maybe there's a project that Garve might be interested in to put in some solar on sort of canopies or something like that. Have an electric vehicle hub, such as is in, yeah, we did this one in Dundee 2 or 3 years ago now. So it's all pretty good stuff. There's also a battery system in one of those wee boxes up the top there that no one's ever told us how well that's working. To be honest, it wasn't us that put that in, but it's certainly there. Batteries, yeah. So if you're generating enough and you're not using it all during while it's being generated, then you've got spare electricity that's coming in, and you can store it up to use later on that evening and overnight. My opinion is that batteries are still too expensive, and if you're looking purely at what they're gonna save you and how much money you're going to make off the electricity that you're putting back into your house during the evening, you will fairly quickly work out that they probably won't pay for themselves in their likely lifespan, is my take on it. And I'm selling them. Okay, so it's simple as that. What is happening though is there is buying and selling now onto the grid, which is called, I think they call it arbitrage, and there's clever and really interesting tariffs that are coming out that are looking at buying and selling and looking at other things. And I think the most important sort of step has been something that Tesla have done with Octopus, which is actually saying, all right, forget the buying and selling thing, we'll just do the whole thing at 11p a unit. So instead of buying your electricity at 16, 17, 18p a unit, whatever you can get, if you put in a Tesla Powerwall, everything is at 11p a unit. So at that point, if you had a heat pump that was using quite a lot of electricity, you've got a big advantage there, and because everything is significantly cheaper to run. So that's the way things are going. What with charging batteries and charging cars and special tariffs, it's becoming interesting. But it doesn't seem to stop people from buying the battery. The cost of the batteries doesn't seem to stop people from wanting to get them and wanting to buy them and wanting to use them, which it's great, really. But we'll see. We've got time for heat pumps. I'll go a little quicker if I can. So we're being pushed towards trying to get to zero carbon emissions by 2045, and we've got a lot of carbon emissions coming from our homes. And hello. Thank you. My dinner's on the table. I'll be along in a minute. It's how to go about reducing those carbon emissions and how to go about actually doing that with the heat in our homes is what we're struggling towards. I think when we're off grid, like we are up here and in Garve, the way to go is to take oil boilers and try and head towards heat pumps. It seems to be the easiest way of looking at it. Probably air source heat pumps seems to be the way forward. The carbon intensity of the grid is falling all the time, and I find it really interesting to look at particular times during the day to see what the carbon intensity of the grid is. And there's a cracking app that you can get on your phone to keep track of it, and it's quite interesting how much you're getting from solar and wind quite often during the days. It's a little heat pump. This is a 5 kilowatt heat pump. Goes into a smaller property or a sort of a modern, highly efficient property or relatively efficient property, and that's all the space it takes up. So that's the external space you need. It is a lot easier to install than some of the difficulties that you might have described with ground source. And that just needs some open space to allow air to flow through the system. So air source heat pumps, I'm talking about air to water rather than air to air, which are air conditioners basically. Air to water heat pumps provide central heating and hot water. They don't have to provide hot water, but they usually are coupled with a hot water cylinder and provide them as well. They draw in heat from the outside air. We've talked about it. They'll work down to -15 and below. Their efficiency basically drops off. The harder they have to work to take heat out of the air, the efficiency starts to fall. So their average efficiency usually over the course of the year is somewhere around that. If your heat pump is doing heating only, it'll be over 400% in where we live at the moment. If it's doing hot water, it has to raise the temperature higher and its efficiency drops off a bit. So you end up with an average of around 300% efficiency, which is exactly what Jamie said. And that's exactly what we're finding when we're going back to service heat pumps. You look in, you see how well they're working, and that's what they tell you. They need to be a well-insulated home. The homes need to be insulated so that the heat pump can run at a lower temperature, so it can get enough heat out into the home so that it stays warm when it's cold outside. So that's where the insulation is really important. Work with underfloor heating or radiators, and they also need a high flow rate so that you can get the heat round the system. So sometimes when retrofitting, pipes have to be changed, radiators have to be changed to allow enough heat to pass around the system quick enough. We do a detailed sort of sizing exercise looking at the efficiency of the building and sizing the radiators for each of the rooms. And Yeah, again, spot on with the numbers that have been talked about, with exactly what Jamie said. I agree completely. The running costs are essentially just comparable with oil. You will not save a lot of money. I would be very surprised if you'd save a lot of money compared to an oil boiler, a decent oil boiler system. But what we're finding at the moment is that people are looking at their oil boilers and going, well, do you know what? We want to move away from oil. We want to get away from an oil boiler. We don't like the idea of this oil, delivery vehicle coming and filling our tank, and it's time to do something different. And yeah, the interest is certainly being driven in that direction. There are government grants that Jamie mentioned, up to £7,500 for the cost of a heat pump, an air source heat pump going in. And you'll probably find that the installation cost will be probably between 10 and 15,000, depending on the size of your property, what needs doing, what doesn't need doing. That's including your hot water cylinder and everything else. So it's about that sort of a level. I'm not going to go into all of that. I can do that later if somebody really wants me to talk through how it works. Cost of oil we mentioned is at about 4.5p a kilowatt hour, which is 50 odd pence a litre. We've mentioned that, I think. And those are the economics. That's the heat pump versus oil boiler. Very, very similar. The running costs are about 560, 570, 580 pounds a year. The difference is that the heat pump on current grid is only going to use about that amount, 770 kilograms of carbon dioxide emissions, whereas the oil boiler gives out nearly 3 tons of emissions. So that's what is pushing this forward. So you need space outside, you need some space inside. You need to be able to put a cylinder. There's quite a lot of pipe work that needs to go in, some electrical control stuff. You don't necessarily need massive radiators, some lovely air and basically fan assisted radiators that are available that'll put out, that's less than 1 meter across, and it'll put out enough heat for an equivalent amount of heat for a 3 meter radiator, just with a bit of fan helping it go round. You can put them on walls if you haven't got space on the ground. You can put the cylinders up in the loft. So practically, yeah, there's figuring to do, but straightforward enough to figure out a way of getting them into quite a few properties. That's about it. Nice little combination there, basically, to do PV that puts electricity into the house, to have a heat pump that takes that electricity and triples it by bringing in the heat from outside. That's what we're aiming at doing quite a lot of the time, and seem to be doing for quite a lot of people, and gives I think the best results. Thank you very much. Any questions?
Thank you, Jason. I think we've got a question here, which is similar to what was asked before, but it says, I think it would be interesting for folk to know more about the sort of differences they might expect from their fuel bills on a monthly, yearly basis. Most, I assume, have oil currently. So I suppose we've answered that question, that it's comparable. Yeah. Phil, have you got something that sprung to mind?
I was quite interested in that last picture. You showed the PV panels and the air source heat pump, and the heat pump was on the south facing wall. Does it matter what wall it fits on?
Not massively, no. You don't want this heat pump sitting in the sunshine all the time, because it's got a thermostat in it, a thermistor in it that knows how warm it is outside. That was actually a southwest facing wall, so yeah, and it's got a bit of a hill behind it as well, so it's not ideal, but from a PV point of view. But you can always put the heat pump under a little shelter, or in a little shelter, just to keep the thermostat right if necessary.
Okay, right. Thanks.
I'd be slightly positive. What we have said on that one is that because you've got solar panels there, if there was to be a heavy snowfall right over that heat pump, if that solar panel was suddenly covered in snow, then they tend to shed their snow quite quickly when it warms up a wee bit, and all that snow would come sliding off potentially and land on that heat pump. So we have said that a little box around it to give it a little roof would probably be a good idea before too long.
Do you ever get any issues with snowdrifts building up in front of them, or that's maybe a consideration? Or
yeah, all those things are absolutely a consideration. We've other prevailing wind is a consideration. If you don't want them looking into the prevailing wind that blows straight at them, because they're trying to blow the heat out the front, so the air out the front, not the heat. And if they're having to work hard because the wind's blowing into them, you'd put something round them to give them a wee bit of shelter. So yeah, the same with a bit of snow. If there's loads of snow and they can't get air through themselves, you need to get your spade out and have a wee dig.
do you provide maintenance contracts or annual contracts for when you install them? Or
We don't do contracts, but we do phone everybody up and try and come around every 12 months to do a service run round our installations as best we can. COVID's made that a bit tricky of late, but yeah, we try and get round everybody sort of you do have to get a service every 12 months, if you certainly within your warranty period anyway, to keep that warranty alive.
What's the rough cost of a service?
We usually charge about £150 for a service, which is the travel and getting to you and doing everything that's needed.
Okay.
That's good to know, Jason, because some installers can charge quite a bit more.
It just depends where you're heading to. If you've got to go all the way to somewhere that's 2 hours away, yeah. But we do the hot water side of things, so the pressurized cylinder service at the same time.
Would you be able to do a better deal then if you had a community that were all getting you coming in to do the service at the same time?
Yeah, if there's the service will take an hour and a half. So if there's a day's worth of work to do, then we'd certainly do our best to bring that price down. That price is sort of based on us doing a whole day's worth of servicing and getting around 5 or 6 people in a day if we possibly can.
I think I might have some other questions written down here. I'll just see if I can find them. Oh, the solar, we sort of talked about that. So the payback time for a standard sort of solar system, is that 10 years then, if on average?
If you're using all your electricity, or a good proportion of the electricity that you're generating, then you're looking at around that sort of just under 10-year sort of payback, if you possibly, is about right. Then, if you're not using none of the electricity that you're generating, then your payback is forever. If you know what I mean. You're not getting a financial benefit from it at all. So it really is how you go about using the generation as best you can. So electric heating.
Is there any particular, because there's a lot of different manufacturers of heat pumps around, have you got any preference or any company that you work with generally?
We install Mitsubishi's, and that's about it. We've done a couple of Valents recently, but only because we couldn't get hold of Mitsubishi's. And I think we just think that it's best to stick with a company that you get to know and get to understand the heat pumps and we find we get good support from them. Technical support is great, and that sort of thing. And they're always there, and they've got a homeowner, a heat pump owner support line you can phone in yourself. They've got something called basically the heat pumps are, if you have Wi-Fi in your house, the heat pumps connect into the Wi-Fi, and all the running information goes basically up to the Mitsubishi website, if you like. So if there is a problem, Mitsubishi can very quickly look into the problem with the homeowner or with the installer and say, actually, this is why it's going off. Once it's tried to do hot water for 3 minutes, it's stopping because, and they're very good. It's very good like that from a diagnostic point of view. So that's the reason, really. We've not had any complaints. We've been installing Mitsubishi's for 10 years now on the west coast of Scotland, and they've been running, without too much bother at all. And they're surviving the weather and the salt really well. Mine's been in for 9 years, I think now, and it really doesn't look old at all or tired. So yeah, we're pleased with them.
We talked about the domestic hot water side, basically making them less efficient because you have to heat the water up to a higher temperature. Do you use external immersion heaters to boost that temperature, or?
They all have immersion heaters in the cylinders, and that immersion only comes on to pasteurize the system. So we usually run them to 50 degrees with the heat pump, and then it's usually once a fortnight, the immersion comes on and takes that up to 60, 65 degrees to do the pasteurization. The immersion is always there as a backup. So if for any reason the heat pump isn't working, you can switch them to just in immersion mode only, and then they'll just do the hot water for you based on the immersion.
So if the heat pump fails, you would still get your hot water out the taps?
You'd still get your hot water out the taps, yeah.
Yeah, that's great.
Interesting switch in philosophy, isn't it? That we've always had it drummed into us to try and use our electric at night, and now you need to think about using your electric while the sun shines.
Yeah. I think so. That's interesting. I think it's interesting that, you know, what are our choices now? We've got to move away from fossil fuels. I think that everybody wants to move away from them, and I think if you're on the gas grid, you know, hydrogen is going to come into play, and you're going to start having sort of hydrogen and maybe hybrid boilers and that sort of thing. But off the gas grid, your choices are pretty limited. I think if you've got an inefficient home that isn't well insulated, you do look at biomass. You have a think about that. But beyond that, yeah, I think a heat pump is the way to go, and it's an electric heating system. And if it's only, you know, it's as efficient as an electric heater in the depths of winter when it's freezing cold outside, as long as it's working, and you're getting a system that's keeping you warm, and it'll make up for that cost during the course of the year. And you'd have a stove with it as well, wouldn't you? You'd have a wood burning stove if you possibly could, is my opinion. And if it's Baltic outside, you put your stove on, and that helps everything along a little bit and keeps you smiling. Great.
Yeah, I was going to ask you a bit about hybrid systems. It's not something that we've just talked about that in the past. You're not a great believer in the LPG combined with air source heat pump. Is that your opinion? It's best just to stick to the one system?
I think you'd only do that if you really had to. If you were in a very large, poorly insulated building, and you were only going to run a heat pump to when it's, you know, -1 or something outside, and you really needed to get more heat than a heat pump's going to sensibly put in. It's more, in my mind, it's more the allowing the boiler to get a higher temperature into your radiators to keep the place warm. So if the system's designed to 45 degrees for your heat pump, and you don't want to push your heat pump any harder or higher than 45 degrees, it's at that point when your building demands something more than that to keep it warm, that you'd switch across to your boiler. But it's added cost, isn't it? You've got two systems to maintain, and it's costly to put in.
Great. Well, thank you. I just suddenly looked at the time there, and I'm sure you're feeling like your dinner's getting cold on the.
Sorry about that. She knocked on my window. What can I do?
Oh, well, no.
Cool.
But shall we just quickly introduce Mark Dale, who's having an air source heat pump fitted at the moment. Are you there, Mark?
Yep, I'm here.
Is that, did you find anything interesting there, or was it all old hat?
Yep, that's most of the stuff that I'd looked at. And the only thing I'll say is that I moved the thing about the air source heat pump was the original position they were going to put it in was next on my patio, next to the sort of table and chairs. And John famously called me to say that's probably not the best position because of the noise. So I spoke to Cruden, and Cruden have moved it, but it is south facing. But the thing was, the original position, because we're quite high up and we get an awful lot of snow, we get big snow falls off the roof, and it would have buried in the original position. I'd have been digging it out every other day over the last few weeks. So for me, putting it on the south facing wall is the best. Plus the prevailing wind is a northwesterly, so it's also the best position for it there. So there's a couple of things I got off Jason there. It was pretty interesting. So yeah, but overall, I'm quite happy with the setup that we've I've come across with this. I have to change 7 radiators to increase the size. The pipe work is big enough, so we didn't have to increase the pipe work, so they should get the flows. But overall, there are 7 radiators that just won't meet the spec. And outside that, I think more on the loan back is I've put the paperwork in for that, got it approved with the help of Jamie, and everything's looking hunky-dory from the point of view. The 28th of this month, Crudens are coming to do the installation, so all's on the go.
That's great news. And did you find, I was interested to know about Fintry were talking about, you missed that early on, the community Fintry were talking about having bridging loans for the deposit, basically for the installer, that was sometimes required. Is that something you found was a problem?
No, that's what I was talking to John about. The trouble is you have to fork out the 13,500 before you can get the 7,500 back. So I was worried for the community, and I'm saying they can't afford it, but the people would have to think long and hard to come up with 13,000, and then obviously get the 7,500 back. You only get it back once it's commissioned, and then you have to have the, through Jamie's been through this, you have to have an EPC carried out, get the report, and then submit it back to Energy Saving Trust for your refund. I have to say, one thing I will say about it is the form is a nonsense. You have to fill out 1 page. When you get the form back, you get 21 pages, and they insist that you photograph the 21 pages and send them back to them. Not the 1 page that you just sign, but the 21 pages in total.
Oh, yes.
There's some legal reason for it. So you have to scan or photograph the 21 pages to send it back, plus your passport or some identification, plus a bill. And there was one other document. I think they were the ones I can think of anyway. But that's the only thing I would say. I couldn't believe it. Obviously, I think you can't post it. They won't post it because of COVID. They won't touch it. So you have to do it that way, unfortunately. But it's fine. It's not the end of the world, but it's just a pain in the backside because it was such a big form that when I sent it to them, they had problems receiving it. And so we were backwards and forwards a few times, and it ended up that there is an email, for some reason, if you use BT Internet, they couldn't receive it properly. There was something wrong. So I had to use an alternative email address, but it's not a big deal, deal. But outside that, it was pretty good.
And then you're going to go for the renewable heating incentive as well, are you?
Yeah. Jamie again helped me with that. Jamie had a look at that. I wasn't sure at first, but he's had a look, and it's worth it from the point of view because you could still get a fair amount back on the RHIs. So it's worth doing it from that point of view. The loan itself, I think, is over 6 years. So I think from the point of view to get the RHIs as well, okay, you're not going to cover every penny of it, but you get back a fair amount, and I think that's more than adequate. And then taking on board what Jason was just saying, I've got an oil boiler. I have a load of problems with the oil boiler I have a heat exchanger, I have a borehole, and the borehole pulls up this water that's really hard, and it blocks my heat exchanger, and I'm changing that every 6 months, and that is not cheap. I can tell you on a Grant's boiler, it comes in at several £100 a shot. So I'm doing that sort of 2 or 3 times a year now. So from that perspective, the old boiler's got to go, and that's it. So
that's good to hear.
Just so you know, you can get a percentage of the Home Energy Scotland loan up front if you need money to pay for the system.
Right.
A deposit.
Yeah, for a deposit. But it sounds like Mark had to pay the full amount up front to begin with.
No, what it is you pay. Good point there. So you pay 20 on agreeing with them. You pay 25%, then 2 weeks before installation, you pay another 45% to the supplier, and then on completion, you pay the final 35%. So in other words, you fork out I'm putting out 13K sort of thing up front, okay? And then what will happen is you wait for the commissioning, and the commissioning certificate will go back then to Energy Saving Trust. And that's when I was told that I should contact them once it's complete.
Do you have the same terms, Jason, or?
Yeah, very similar. And we're bound by the microgeneration certificate. Well, it's by REC, by the Renewable Energy Consumer Code, and there,
okay.
I think you can. Yeah, it's 25%, and then up to, I think it's up to a maximum of 60% or 65% as a total deposit. We do very similar. We usually don't bother with that 25% up front, and we just ask for an amount that covers the cost of the heat pump, which is usually less than that 65%, a couple of weeks before we're going to install it, so that we've covered ourselves when we're buying it, essentially. Yeah.
I think the issue, well, I'll be honest, the issue is that everybody struggled through COVID, and there's a risk, obviously, when you're forking out this sort of money, that you have to be sure that the company you're dealing with is obviously in a good financial state. So you know, it's a worry, but as I say, the companies that you deal with, you've just got to be sure that they can get through it, so to speak.
Yeah, if companies take a deposit, they're meant to take out deposit insurance for you, right, through the Renewable Energy Consumer Code, and they're also we also have to take out something, basically workmanship warranty insurance as well. So if we go bust in the next couple of years, you're insured that some other installer will come back and fix your heat pump if we can't, basically do it for you because we're no longer in existence. So that's what the Renewable Energy Consumer Code's meant to do. But we don't feel we're taking a deposit. We feel we're spending your money and getting you a heat pump, and that heat pump is being delivered, and we can drop it around at your house as soon as you want, sort of thing. So you've got it yourself. Yeah.
Okay, well, we look forward to hearing more from you, Mark, and once you've got this thing installed. And we discussed about possibility of having, you could look at your bills in a year's time and do some cost comparison with the oil and all that. That would be great to hear back from you.
Heart. It might upset me. And then my wife will really be on my case.
Yeah. Have you got a wood stove as well, or a wood burner?
I've got 2 wood stoves, just to make sure.
Well, you might be out there chopping firewood then, eh?
I'm up for that, don't worry.
Yeah. I'm sure it'll go well.
Thank you.
Okay, well, we're nearing the end of this. Well, we've gone over as usual, so I'm not going to talk about biomass. I would say that I live off grid, so I can't install an air source heat pump.
It's true.
So for me, the only option was to look at pellet stoves. So I've got a really nice small pellet stove. It's about 18 kilowatts. And I went through the Home Energy Scotland loan system and RHI, and it works really well for me. I'm quite hands-on. There's a bit of ash cleaning. It's not totally maintenance free, so every 4 or 5 days I go and empty the ash pan, and you get this brush out and you do a bit of cleaning, and with a vacuum cleaner handy. It's all much cleaner than having to use an old style wood burner or coal. So I'm very happy with it, and I get the full RHI. So strangely enough, I'm actually going to come out at the end of the 10 years with a slight profit. So the RHI is going to pay for the loan that I took out and a little bit more. With RHI, you have to do an annual declaration. So you get an email saying, are you still using this system? And you basically go onto the government website and fill that out and just say, tick the boxes, yes, I am. And that's just really to make sure that nobody's decommissioned the system and still getting the payments, for instance. But it's a good system. And we should also mention that the RHI is actually coming to an end next year. So if anyone wants to look at renewables right now, is a good time to be trying to get something put in, because we don't really know what's going to happen after April next year. Will there be a new scheme to replace the RHI, or will the government coffers be empty? Yeah, so it's good if anyone's considering it now, do get in touch and we can see what we can do to move it forward. Yeah, thank you. So thank you to everyone for coming for this second meeting, and Jamie's looking for his dinner now, and so am I. I think I'm going to have to cook myself tonight because I'm home alone. But yeah, and it's great to have had you all along.
Ewan, there's just a very quick question in chat. Jason, do feel free to go. I'm worried about your dinner going forward.
Where's the question is, quick question. If you have colder rooms in a house, does the pump then have to work harder to maintain a constant heat in the whole of the house? Is that something you can answer, Jamie? Sorry, not Jamie, Jason.
I'm not sure I understand. Let's go and say that again, Ewan. If you have
if there's a cold room in the house, do you have to heat the whole house with an air source heat pump, or is it advisable? And does that mean that you're going to use more energy to heat your house?
I still don't quite understand. So if there's one room that's particularly cold and it's not heating up and all your other rooms are heating up well, then I think I would check your insulation out in that room, figure out why it's so cold, and if it's not heating up and the radiator's warm, then you obviously need a bigger radiator in that room to get enough heat out. If that's what the question is. If that isn't what the question is, and the question is you've just got one cold room and the rest of the house is perfectly warm, does the heat pump need to come on to heat that room? What would happen is, like any other heating system, you'd have full control over each of the rooms. So you'd have a central thermostat bringing the heat pump on, switching it off. So as long as that thermostat was calling for heat, you'd have thermostatic radiator valves on each of the individual radiators. So all your other rooms, apart from that central one with the other thermostat, with a wall thermostat in, would have radiator valves switching those radiators off, and it would focus the heat basically into that one room that's cold, that's wanting warmed up.
I think what in my experience as a builder and working with heating systems, this is often a problem when there's old pipe work in the house, or it's been poorly designed in the first place, so the water isn't flowing to that particular radiator. And as you say, if you don't have radiator stats that turn themselves on and off, then the whole system can become unbalanced. So with a new radiator system and pipe work and an air source heat pump, you should actually get a much more even distribution in the house.
Yeah, I got the impression that the question was maybe referring more to, if you've got a spare room that you're not using, do you need to keep that warm if you're using an air source heat? Which I suspect the answer is no from what you described. You can control each room to the heat you want.
Yeah.
Although from a builder's point of view, I would say try not to do that. At least put the stat down to a lower setting, so it's giving some heat to that room, because what can happen is you've got a lot of warm air in other rooms, cold air in that room where you've got the radiator turned off. You'll start getting damp potential problems there with condensation forming. Would you agree, Jamie?
Yeah. So you don't really want to go below 14 degrees in a room for a long periods of time. So setting it about the second setting on a radiator stat is usually enough.
Okay, Gordon's going. Thank you, everyone. Thank you, Gordon. Thank you, Kate. Thank you, Jason. Thank you, Jamie.
Right.
And
cheers, thanks everyone.
And thank you, Mark, for coming along.
Cheers, then.
Great. Bye. I'm going to say goodbye to everyone.
Okay, thank you. Bye.
Thank you all for joining us.